Okay po. So, okay, start na tayo. Ano? Share screen. Okay. And then dito, I'm already sharing my screen. Ano? So, pa-check na lang po if hindi po lumalabas sa inyong side. But ayan. Okay. So, today's topic will be talking about schedule design. So, continuation siya. So, ng product design, process design, schedule design, which are needed in order for you to design the facilities. Okay. So, dito sa schedule design, again, short discussion lang naman to. Madali lang. So, short discussion about schedule design. So, when we talk of schedule design decisions, we're trying to provide answers to questions involving like, uh, di ba, when we talk of schedule, di ba, tinitingnan natin, it's more of a plan. Ano? So, ano ba yung pinaplano natin? Ano yung mga questions na kailangan nating i-answer? So, dito, schedule design, it provides answer to questions involving like how much one has to produce, ayan, and when, or yung timing, when to produce it. Okay? So, tinitingnan natin gaano kadami yung kailangan mong gawin at yung timing ng pagpaproduce sa kanila. So dito sa schedule design, meron tayong dalawang klaseng decisions. First one is yung tinatawag nating production quantity decisions, which are normally referred to, may tinatawag dyan, lot sizing decisions. So lot size, gaano kadami, yun yung quantity. How much do we need to produce? Okay? And then yung another part ng decision, schedule design, is yung timing. Ito nga, timing, which we refer as production scheduling. Okay? So itong dalawang scheduling, so itong lot size decisions, determining how much of a product you have to produce or what is the production quantity and the timing as to when that particular item, that particular product has to be produced. So yung dalawang yan yung kino-cover ng ating schedule design. So in addition, how much and when, in addition to how much and when to produce, it is also important to know, syempre, how long yung production natin will continue. If you are designing a facility, alam mo na dapat kung kailan yung end of life ng product mo. Kasi may mga business tayo na nag-i-span lang for 10 years, for 5 years, and then later on, mag-i-introduce sila ng new product. So yung decision natin, hanggang kailan ba tayo kailangan mag-produce, kailangan may consider. Ano? Okay. Kasi if you're buying, for example, raw materials, so that should be enough to cover yung duration ng project na yun. Okay? Hindi siya pwedeng lumabis kasi pwedeng mag-excess yung mga materials na yun, which is ayaw naman natin, masasayang. It will turn out to waste. Okay? So, we can determine kung hanggang kailan maglalas yung production natin by determining yung ating or by doing market research or market forecasting. Through market forecasting, you can determine hanggang kailan maglalas yung project. Okay? May nag-interrupt ulit. Okay. So dito po sa process, sa schedule design natin, may tinitingnan tayong 3 phases. The first phase is determining the quantity of components that must be produced. Let's say your product is composed of several components, so kailangan malaman natin through bill of materials gaano kadami for each component na kailangan natin to produce yung number of finished goods na yun. Also, hindi lahat ng components ay nako-convert natin into finished goods. Halimbawa, for example, this is the bag of resin. Sabihin natin 1 kilo. Okay? Pero hindi buong 1 kilo yung magagamit mo. Posible, meron ditong mga wastes tayo or pwede nating masabi as scrap, sabihin natin, or defects na posible mag-account ng let's say mga 2% of that 1 kilo. So ibig sabihin, ang usable lang dito ay nasa 98%. So you must understand na hindi lahat ng components natin ay magagamit sa finished goods. Hindi lahat. So we must consider allowances for defective items. Okay? The second piece is determining yung ating machine requirements for each operations. Dito tinitingnan din natin yung timing. Kailan ba ako magkakaroon ng machine? Saan ko ba ilalagay? Then the third for the schedule design phase is combining yung operations requirements to obtain the overall machine requirements. Paano ba natin may utilize yung mga machines na meron tayo, yung ating operations, paano niya magagawa yung or paano natin mai-combine yung mga operations na yun para ma-utilize natin ng maayos yung mga machineries. Saan natin ilalagay yung mga machineries. Okay? Okay. So dito sa ating okay, so question so far. Again, short discussion lang to. Questions? Since wala. So dito may tinatawag tayong calculation for production requirements. So once again, hindi lahat ng item ay magagamit natin. For example, may kinoconsider tayo mga tinatawag nila as scrap percentages. Let's say for example, ito yung component mo C001. Ang typical is sorry. Ayan. Then C002, C003. Ayan. So, ayan, halimbawa, isang unit yung kailangan sa bawat component na yan, pero syempre may scrap quantity kang mai-consider. So, hindi dapat, so kailangan may palabis ka, may mga tinatawag na allowances pag nag-i-schedule. So, kung 1 to, posible ang bibilhin mo or ang isasalang mo sa machine ay sabihin natin 1.01 kilogram. Okay, so parang ganyan. Ito, so that 1% will account for allowances. Okay, defective allowances. Lagi po may ganyan, mga scrap allowances. Okay, so then sabihin natin ito naman po, sabihin natin mas malaki yung scrap niya. So 1.05 kilogram. So kung ito ay 2 kumbaga, so dapat siya ay 2.02 kasi 1%. Okay, and then so on so forth. Okay? Pero may formula tayong ginagamit in determining yung mga allowances na yan. Again, we have this input. Ito yung output natin, but not all inputs ay nagiging good parts. Meron tayo ditong defects or scraps. So we have here inputs. We have here outputs. Okay? So kumbaga, kung meron kang 5% na defective allowance, ayan, so ang ating magiging ang kailangan mo halimbawa ay 25 pieces. Gaano karaming inputs yung kailangan mo? Okay, or kailangan mo isa lang or kailangan mong ilagay sa machine. Okay, so we may use this formula. So whereas DK is the percentage for defective items produced in the kit operation, O sub K, desired output without defects, and then ito yung production input mo. So masasabi natin, okay, may mali dito. Dapat ito ay minus sign. Ayan. Okay, O sub K is equal to I sub K minus D sub K times input times, ayan, times the defect rate. Or pwede nating mailagay ay 1 minus defective rate times the input. Or pwede rin nating baliktarin if let's say we're talking of the input rate. So output rate is 1 minus D sub K. So kung babalikan natin to, I need 25 pieces. So ang output mo ay 25 pieces. Let's say ang defective percentage mo is 5%. Gaano kadami yung isasalang mo sa machine? So we have input is equal, so sundan lang natin to, 25 divided by 1 minus 0.05. Tingnan natin kung anong result. Okay. So once again, I have here an output, defective percentage, and then I have here the input. So if my output, kailangan ko ng 25 pieces, then I have a 5% defective rate. So gaano karaming input yung kailangan ko? So 25 pieces divided by 1 minus 0.05. So ibig sabihin, kailangan ko pala po ng 26.32 pieces. Or pwede nating approximate, kailangan ko ng 27 pieces. Okay. So 27 pieces, kung babalikan natin to, so 27 pieces yung sinalang ko, ang output natin magre-result lang tayo sa 25 pieces. Ibig sabihin, yung 2 pieces dyan ay possibly scrap. Hold on, ipapakita ko sa inyo kung anong importance yan sa planning. Log-in lang ako sa system namin na. Okay, hold on. Ipapakita ko sa inyo yung percentage na yun na sinasabi. Kasi kailangan siyang mai-consider when we are planning for raw materials or for the component parts. So, babalikan nga natin dito. That's the first phase. We have to determine ano-ano yung mga component parts na yun, gaano kadami ang kailangan in order to build a particular finish good. And then, may consider dapat din yung mga defective percentages. Okay. So, this particular item is a finish good part. And then, ito yung sinasabi ko sa inyo na plan. 52,000 pieces. So, kung titingnan natin, yung 52 pieces na yan, and then i-consider natin lahat mga component parts sa kanya, especially yung 1:1. Ito halimbawa, or sorry, hanapin natin yung 1:1. Ito, nakita nyo yun? So, ang plano ko ay 54. So, this is a bill of material. Ano? Ang plano ko, I'm planning for 52 pieces. But then, I'll be requiring 54,860 pieces ng component na to. Okay? So, ibig sabihin, may kinonsider tayo na allowances. So, kung i-recompute natin, kailangan ko ng 52 pieces. Sorry, ilagay ko dito. 52,000 pieces. That's my plan for the finished goods. And then for the input ng mga raw materials, sabihin natin na 1:1 siya. So, ano yung nakalagay dito? 54,860. 54,860. Gaano karami kaya yung defective rate niya? So, kung babalik na rin natin yung formula, ang formula nito ay ganyan. Okay. So, kung babalik na rin natin siya, it's equal ito divided by yun minus 1. So, yan yung kanyang percentage defective. So, double check natin if tama pa ba. Oops, mali yata ako. Baliktad ako. Ayun. So, dapat pala ganun. Palibasa, hindi ko na dinerive yung formula. Ano? So, 55.21% yung ginagamit natin na defective rate. So, ibig sabihin, once again, if I need 52,000 pieces, my component, I'll be needing 54,860 given that I'm considering 5.21% of defectives. So, tingnan natin kung tama bang 5.21% yung defective natin. Ayan. So, ito yun. So, almost close naman, 5.21 against 5.48. Ito may kinoconsider pa rin lote sa lot size eh. Kaya medyo hindi natin may consider na exact. Kasi depende yan sa lote. Kada box, kumbaga. Pero ayun, close naman yung computation natin. 5.21 nakalagay sa system as an assembly scrap is 5.40. Questions? Check na uli natin. So once again, the plan is 52,000 pieces. And then if you look dun sa bill of materials, ito lang yung tinignan natin isang to kasi ito yung madali. Ayan, 1:1 siya. Sa bill of materials, check natin. CS 15. Hold on. Oops, sala. CS 3. Ayan, so tingnan natin ulit yung bill of materials kasi nag-expect tayo na 1:1 siya. Ang component na tinignan natin is 899,559. This particular item. Okay? So once again, kahit 1:1 siya sa bill of materials, parate may kino-consider tayo na allowances for defects. Questions? Nakuha po? Okay, good. Now, let's continue. Okay, so naibigay naman natin yung sample na to. But again, it vary depende dun sa lot sizing. Kung babalikan natin, that is this case, lot sizing. Kasi pwede kasing nakabatch per batch. Per batch. Halimbawa, 10K pieces per batch. So, ibig sabihin, dito i-consider yung percentage defectives at hindi dun sa mismong target mo na 52. Kasi, halimbawa ito, 52,000, isang lote ang kinonsider natin. Ano? Kaya hindi natin nakuha ng sakto dun sa kung ano yung nakadeclare sa system. Nevertheless, same lang din naman yung formula. So kayo po, as dito sa facilities planning, hindi naman natin goal na hanapin yung percentage crop. Normally, siya ay determined na. Alam na natin. But kailangan siyang i-consider sa pagpaplano how much of the space ang kailangan to consider those scrap percentages. Kasi nga, hindi naman 1:1 palagi yung gagamitin. Hindi naman kung ano yung nakalagay sa bill of material ay exactly yun na. Laging kino-consider yung scrap allowances. Okay? So ngayon, if your product requires or needs sequential operations, halimbawa po, we have multiple processes. Process 1, process 2, process 3, ayan, process 4, may multiple processes. And then at the end of the process 4, you need a certain output. The question is, gaano karami yung input mo? Again, kada processes, meron siyang nakukuhang defects or scrap. Ayan, so paano natin malalaman yung input na yun given that I need, let's say, for example, a certain value of output, a certain quantity of output. So we may use this formula. Output N is equal to input for the first process multiplied by, ito po yung input sa first process multiplied by 1 minus d sub 1. D sub 1 is for the defective rate dito sa process 1 times 1 minus d sub 2 process rate for the defective for the process 2 and then so on and so forth. For the input, i-reciprocal lang. Okay? Ngayon, let's try to have a sample. Or sige, isa muna dito. Let's say you have two processes. Ito si process 1, ito si process 2. Okay? Then, yung inyong components ay dadaan ng process 1 and then dadaan ng process 2 para magi siyang output or magi siyang finished goods or level 0. Let's say you need two pieces here. And then process 1 require 1% dito. 1% defective. Gaano karami yung kakailanganin mong input dito for your components? Okay? So, di ba yung input dito sa process 1 ay mangyayari may output dito. And then, yung output na yon yun yung magiging input dito sa process 2. Okay? So, kung titingnan natin, dito muna tayo sa side na to. Pwede bang palitan ko ang mouse pointer? Hold on. Okay. So, tingnan muna natin itong first phase na to. Okay. So, hindi natin siya agad masosolve kasi wala tayong makikita. So, kumbaga para itong output sub 1 is equal to the input sub 1 divided by, or kung babalikan natin dito, ito po. Okay, erase. Pwede ba yung eraser? Eraser. Okay. Ayun. Yes. Okay, then 1 minus defective sub 1. So, kung ilalagay natin dito, wala tayong input sub 1, hindi pa natin alam. So, input sub 1 times 1 minus 0.01. Okay, so you have the output sub 1. Okay, then that output sub 1 ang gagamitin natin as input for the process 2. So, kumbaga, ang output 1 ay equal sa input sub 2. And then, kung titingnan natin to, yung banda dun, So you can consider output sub 2, which is 2 pieces, times input sub 2, 1 minus 0.01, which is, ayun nga. So ang titingnan natin, input sub 2 is equal to output sub 1 times 1 minus 0.01. And then yung output sub 1 is equal to the input. So pwede natin ilagay dito, input sub 1, 1 minus 0.01. I-multiply ko ulit sa 1 minus 0.0. Hindi na kasya. 0.01. Ayan, pagkasyahin na natin doon. Ayan. Or, ilagay natin siya dito. Kumbaga, yung output sub 2 mo is equal to the input sub 1 multiply by 1 minus 0.01 para dito sa first process. Ito po yung na-consider natin. Yung banda dyan. Times 1 minus 0.01, which is yun pong kabiak na yan. Okay, which is aligned sa kung ano yung nakalagay dito. So kung kukumpitin natin, 2 is equal to input sub 1 multiply by 1 minus, or simplify na natin, 0.99 times 0.99, that we can then figure out ano ang input 1. Okay? So, that case, siya ay equal to divided by 0.99 times 0.99. So, 2.04, which is justifiable nga. Kasi mas madami dapat yung input mo kaysa sa output. 2.04. Okay? So, again, pinakita lang natin yung derivation nito. Ngayon, questions po before we proceed sa another example. So, kung yung inyong input ay mas malaki kaysa sa output, so tama siya. Pero kung mas maliit, may something wrong dun sa ginawa niya. Okay, kasi we expect na may defects na mako-consider dun sa ating mga inputs. Okay. So, kung walang question, proceed tayo dito sa example. So, let's say may isang product daw na may market estimate na 97,000. And mag-undergo siya ng 3 steps, which are turning, milling, and drilling. Ayan. And then each process has the defective percentages of 0.04, 0.01, or 3%. Ngayon, ang kailangan nating hanapin, gaano karami yung inputs natin to produce 97,000. So again, this is our goal. Goal output, 97,000. Okay, so kung ilo-drawing natin, ito yung ating input. Ito yung ating turning process. Siyempre, meron ditong defective. Ito yung second step natin, which is milling. Meron dito uling defective. Third process natin, which is drilling. Meron ulit ditong defective. Okay? And then, syempre, kailangan mo dito ng 97,000. So, ilagay lang ulit natin yung mga percentages or defective allowances. Okay. Ngayon, I need to produce 97,000. Gaano kaya karami yung input natin? So, kung titingnan natin, kung babalikan yung formula, parang ito yung susundin natin. Ano? So, let's just put it here. Input is equal to the output divided by 1 minus D1, 1 minus D2, 1 minus D3. Okay, solve natin. Ano ang output? We have 97,000, 1 minus 0.04, 1 minus 0.01, 1 minus 0.03. Double check natin if we're doing it correctly. So ito po yan. Okay, ito po yung ating tinitingnan. So, ano po ang ating input?
Sir,
Yes.
pabalik nga po doon sa formula. Parang may isa pong may yung one.
Itong 1 sa taas. Ito po. Yes. Apo, i-multiply lang. ON all over 1 minus D1, 1 minus D2. Ayan. Okay. Okay pa? Okay. So, tingnan lang ulit natin. So, I have here 97,000, 0.96, 0.99, and then ito po, 0.97. So, what I'll have to do is multiply ko lang tong lahat ng yan. And then, ito ay i-divide ko dito. So, therefore, I need 105 to 19 pieces. So, imagine, I need 100,000 para 100,000 of the components to ensure na mapoproduce ko yung 97. Okay, or I should plan for 105,000 of the finished goods for me to achieve that 97,000. Okay? Ngayon, pwede nating tingnan siya pabalik. Di ba yung output or itong 97,000, that's the output of the drilling. And then meron ditong input. And then meron ditong output. Then meron ditong input. Then meron ditong output. Kung titingnan natin siya pabalik, gaano karami kaya yung input dito sa drilling? Okay, so balikan lang natin. So, 97 divided by 1 minus 0.03. Okay, so saan siya galing nga pala yung formula? Ito, tinitingnan ko to. Itong formula na to. Again, iisa-isahin natin. Tingnan lang natin kung anong resulta. And then, may evaluate natin kada process, ano dapat na input. Okay? So, I have here equal 97,000 divided by 1 minus 0.03, 100,000. So, kailangan ko pala dito ng 100K and produce 97,000. Ngayon, itong output na to ay dapat 100K din. Then, ito yung ating defective rate, 1%. Anong input? So, equal ito divided by 1 minus 0.99. Kasi 1% yun. Enter. Okay, sana tama ako ng ginawa. Isa pa. So, once again, I need the 100K. Oops. Okay, baliktad pala ako dun. Okay, double check natin. Ayan. Then, divide natin. Sorry. Kailangan ko ng 101 dito. Okay? So, ayan. So, ang input pala dito sa milling process ay 101,000 to produce 100. Ngayon, yung output dito ay equal din dun sa input dun. May 4%. Anong input? Dapat the same. Di siya dito, 105 to 19. So, tingnan natin. Equal divided by 1 minus 0.04. Ayun, the same naman. 105 to 19. So, if we are to summarize it, parang ganito yung process. We have the input. We have here the output. Ito yung kada process natin. We have the turning, milling, and then drilling. Ang input niyan input ng drill ng turning as a first process is 105,219. That will give me yan pieces na yan. Okay, and then yan yung input natin dito. Ito rin po. That would result sa 100K. That 100K is also the input for the drilling process kasi sequential naman po sila. Then that would result sa 97. Questions? Nakuha po?
Wala po, sir. Opo.
Nakuha. Okay. So the challenge here is paano nyo siya ipapa-implement or paano siya i-recompute dun sa ating ginagawang consolidation dun sa Excel file natin. Okay. Meron na ba kayong market study dun sa inyong hindi nga pala product design yung ginamit nyo, Okay. Okay lang ba na ganito? Dun po sa mga ang product nila ay gagamitin sa feasibility study. Makukuha naman natin yung market estimate or yung forecast for the whole year Sana po meron ng ganun. Pero dun po sa mga wala pong feasibility study pa or yung product na ginagamit nila dito sa ating project ay hindi pa pang feasibility study, okay lang siguro na mag-estimate kayo ng let's say 100,000. Maglagay lang po tayo ng market estimate para ma-recompute natin itong mga inputs and output ng kada components. And then yung mga processes ay kailangan din ma-determine na natin. So makikita naman natin siya dun sa ating routing or sa ating route sheet yung mga processes niya undergo. And then you can estimate defective percentage. Ito hindi ito trabaho ng facilities planner yung market estimate or itong scrap estimate. Ito normally ay mula sa process engineering. Sila na yung magbibigay sa atin or process and product engineering. Sila magbibigay sa atin ng mga defective percentage. Pero for the meantime, i-estimate din natin to. Okay, so that would be for our schedule design. Siyempre, may additional pa dito kasi we're on the first phase pa lang. Dito pa lang tayo sa first phase. Then for the next meeting, we'll consider computing for machine requirements and operations requirements. Para alam natin ilang machines ang kailangan natin na ilagay sa planta para makapagplano tayo o makonsider natin yung lahat as we go as we design for our facilities. Okay? Questions? So, dapat po yung mga naunang activities natin ay maayos yung output kasi kakailanganin siya sa mga susunod na lectures natin. Questions? Questions po?
Sir.
Wala naman po. So, for now, wala po tayong gagawing assignment dito. Tatapusin muna natin yung machine requirements and operations requirements sa next meeting. Okay? Which is on Thursday. Okay. So, walang questions? We're good? Maaga tayo ngayon. Hindi tayo So, questions po? Wala na? Okay. Good. So, I think that's all for today muna. For our 1 hour discussion. And then see you. Yes? Sa grouping. Sino to? Si Maldonado. Bakit po wala po kayo sa class list? Opo, pero nag-check na enroll nyo ba yung sa Yubian? Kasi I'm referring dun sa Yubian niya. Sir. So, may problema tayo dyan, sir. Kung hindi kayo nag-enroll dito sa Yubian. Ay, paano po yung kasi ito po ang gagawin natin sa supply chain ay more of ifa-follow lang natin to. Tapos ako'y mag-i-input na lang. So please, ayos naman po.
Sige po, sir.
Ito po yung code. Ibibigay ko po sa group chat. Okay, ayoko na patapos ang SEM saka kayo lalapit sa akin. Hindi na yun acceptable.
Pasensya na po, sir.
Okay? Questions? Questions pa po?
Ano na?
Okay, so ayan, matcha-check na naman po yung PowerPoint natin dito sa facility scanning session dito po. Check na lang po yung dito po. Schedule facilities design. Okay. So ayan, continue. Kung walang questions, I think that's all for today. Salamat guys and have a great day.
Thank you po, sir.
Thank you po.
Thank you po, sir.